Okay, so get ready, because today we're diving into AI and language.
Okay.
You know how we're always hearing about those LLMs, those large language models?
Right.
Well,
Yeah.
what if
Mm-hmm.
they don't experience time the same way we do?
Whoa. That's a really interesting question.
Right.
Yeah, because I mean, we think of time as so linear,
Yeah.
always moving forward.
Hmm.
But for these LLMs, they're basically prediction machines.
Yeah.
So time gets a little fuzzy.
It's true. They are predicting the next word
Yeah.
in a
I
sentence
took that.
based on all the mountains of data we feed them.
Yeah.
But what happens if you reverse that?
Uh,
What if instead of predicting what comes next,
okay.
we challenge them to figure out what came before?
I like that.
Right.
So that's what researchers wanted to figure out. They explored this idea of time directionality in LLMs.
Time directionality.
Yeah.
Okay.
And think of it like this. Imagine you're reading a book,
Okay.
but you're reading it backwards.
Backwards.
Yeah.
Okay.
You're still processing the words,
Mhm.
but it's just not the same.
The flow is all messed up.
Exactly. The logic is disrupted.
Yeah.
Yeah.
So how did they test this with LLMs?
So they trained two sets of models.
Okay.
One set was trained to predict the next word in a sequence,
Okay.
like
Wait.
normal, just like we normally use language.
Yeah.
The other set
Okay.
was trained in reverse
Oh, wow.
to predict the previous word.
Interesting.
Yeah. So one group is going with the flow of language and the other one's like swimming upstream.
That's a great way to put it.
Yeah.
So predicting backwards, though, it seems like it should be just as easy as predicting forward.
Right. You think so?
All the information is there.
Yeah, you would think it would be a piece of cake, but it's not.
Really?
That's not what they found. The results were really unexpected.
All right, so what happened?
The models that were trained to predict the next word,
Mm-hmm.
those following that natural forward direction,
Okay.
they were consistently better
Interesting.
than the models trained in reverse.
Wow, so even AI has a preference for how time flows
It seems that way.
in language.
Yeah, like there's some hidden rule book.
Yeah.
And that difference in performance.
Yeah.
That's what the researchers are calling an arrow of time, or AOT.
An arrow of time. I
It
like
does,
that.
yeah.
So language itself has a built-in direction.
It seems that way.
This isn't just something we made up.
No, it's really interesting.
Yeah.
And to really understand why this is so important, we
Okay.
can look at an experiment the researchers did
Okay.
using prime numbers.
Prime numbers. Okay, now you've got me really curious. Prime numbers.
Yeah.
Okay, how do those fit into all of this?
Okay.
This arrow of time business.
The researchers trained these LLMs
Okay.
on a special language
Okay.
instead of words and sentences.
Right.
It was equations.
Mm-hmm.
And on one side of the equation, you'd have two prime numbers multiplied together.
Okay.
And on the other side, their product, but with the digits reverse.
So like 7 times 11 is 77.
Yeah,
And you reverse that and it's still 77.
exactly.
Okay.
Not very challenging, right?
No, not really.
Even for us humans. But then you multiply larger prime numbers,
Okay.
like 19 and 23,
Right.
you get 437.
Right.
Reverse that, you have 704.
Well, okay.
Suddenly it's not so obvious what
Right.
the original primes were.
Not at all.
Right.
I mean, I can barely multiply those in the first place,
Yeah.
let alone figure it out backwards like that.
Exactly.
So this prime number experiment,
Yeah.
it's telling us about how these LLMs handle information,
Yeah.
even if it's not traditional language, right?
Exactly.
Yeah.
It shows that reversing certain computations,
Mm-hmm.
like factoring those large numbers, it's
Yeah.
just inherently more difficult.
It's like trying to unscramble an egg or something.
Exactly.
Like you can scramble it up, no problem, but good luck going back.
Yeah. And it's like that, even though the information's all there, it's just harder to go back.
Yeah.
And that seems to be reflected in the way that LLMs process language as well.
So this arrow of time,
Yeah.
it might not just be some weird thing with AI,
Right.
but actually something fundamental about information itself.
That's the million-dollar question.
Wow.
And, that was just the tip of the iceberg.
Yeah.
They actually found even more clues when they started to look into something called sparsity.
Sparsity. Okay, what is that? Okay,
Okay.
so we've gone from AI predicting words to prime numbers to libraries.
It's quite a journey.
My brain is feeling a little fried right now.
Yeah.
But I have to ask,
Yeah.
what does this all really mean?
That's the question, isn't it?
We've uncovered this hidden arrow of time
Yeah.
in language and information,
Mm-hmm.
but why should we care?
Well-
Like, what's the big deal?
To help answer that,
Okay.
let's think about two people who are trying to learn a new language.
Okay.
Let's call them Alice and Bob.
Huh. Alice and Bob classic. And
You're going to learn a new language.
Alice, she's fluent in this new language.
Okay.
And she wants to teach Bob.
Okay. That's good.
So imagine this new language is structured in a really sparse way.
Okay.
Like we were just talking about, with a few clear rules,
Mm-hmm.
not too many rules,
Right.
some predictable patterns.
So it'd be kind of easy to learn.
It'd be pretty easy to learn.
Yeah, like learning a dialect of something you already know.
Exactly.
Yeah.
But now imagine there's a third person, Carol,
Okay.
and Carol processes information in reverse,
Okay.
like those backward predicting LLMs we discussed.
If Carol tries to learn the same sparse language
Right.
that Alice and Bob are learning, it's going to be way harder for her.
So even though this language is sparse,
Right.
it's not going to feel very sparse to her
Exactly.
because she's processing it all backwards.
Yeah, it's like that jumbled library all over again.
And this is telling us that
Yeah.
languages, even artificial ones,
Mm-hmm.
don't just exist in a vacuum.
Yeah.
They evolve over time based on how they're used and learned.
Exactly.
So this bias toward forward information flow,
Yeah,
is it embedded in language?
it's a good question.
Because that's how our brains are wired.
It's possible.
It's like we're so focused on the what of language, the words, the grammar, the syntax,
Yeah.
that we've totally missed the how our brains naturally flow forward.
It's like we're revealing this hidden layer.
Yeah.
Yeah.
And it might be reflected in reality itself.
And that's where it gets really interesting.
Okay.
Because what if this arrow of time,
Yeah.
it's not just some weird thing about language. What if it's a fundamental principle
Okay.
of how information processing works?
Whoa. Okay, hold on.
Yeah.
So what are we talking here?
Time travel?
Maybe not time travel,
Okay.
but it could change how we design AI.
Okay. How?
We could design AI systems
Yeah.
that are aligned with this natural forward flow.
So they'd be more efficient. Potential.
We'd be going with the flow.
Yeah.
And it's bigger than AI.
Really?
Think about physics,
Okay.
biology,
Mm-hmm.
economics, even.
What if this arrow of time
Yeah.
helps us understand how complex systems
Yeah.
evolve and change over time?
So this one question, can AI experience time differently,
Yeah.
has opened up so many more.
It's like we're looking at the operating system of information itself.
That is a great way to put it.
And that's what's so cool about all this.
Yeah.
You start with a simple question, and you end up with a million more.
That's what the deep dive is all about.
Exactly.
Taking our amazing listeners
Yes.
on these journeys of discovery.
It's been quite a journey.
It really has. And it leaves us with one final thought.
Okay.
What if this arrow of time isn't just a feature of our universe?
Yeah.
What if it's a fundamental property of any universe
No.
that can support life intelligence?
Yeah.
Maybe even a good podcast or two.
I like it.
Until next time, keep exploring, keep questioning, and keep diving deep.